right. Well, welcome back. And we're going to talk about today is another application of using the law of sines and cosines. And what we have right here is the good old flagpole problem. These can be a little bit complicated, so I'm going to take my time to try to help you through it. So what we have a flagpole, all right, at a right angle to the horizontal. Okay, right angle to the horizontal. So when we're doing this, it says to draw a triangle and some pictures. So I'm going to do that right away. And what we have is this horizontal, and what we have is a flagpole that's going at a right angle right here. Okay, so that is a very bad looking right angle, so I'm just going to erase that right there. But we have a right angle going straight up. Okay, that's a little better. All right, and we have right there. Now, it says locate on a slope that makes an angle of 12 degrees. Okay, so we have a slope right here. We have a 12-degree angle. I'm just going to draw it like that. Okay, so this angle right here is 12 degrees. All right. The pole's shadow is 16 meters long and points directly up the slope. All right, so right here, here's our slope and here's a flagpole. So we have a shadow that goes directly up here, which is going to be 16 meters. Okay, so we'll just say this is 16 meters, goes right up here, like so. All right, and points directly to the slope. The angle of elevation from the tip of the shadow to the sun is 20 degrees. Okay, so from the tip of the shadow, so wherever that is, I'm going to just erase that portion. So from the tip of the shadow to here to the sun, all right, we'll just say that. Now I'll draw this up a little bit higher. Okay, right there. This angle of elevation, now the angle of elevation, this is going to be 20 degrees, 20 degrees. Okay, so this is what we know, and we have to figure out all this other stuff right here. We have to figure this out. So we want to figure out what is the height of this flagpole, and here's our flagpole right there. And if you want to put a little flag in there and go, America. All right, so there's our flag. All right, in doing that. And from here, we want to figure out all these different things. So we have a side, and we need this side. So we have to know this angle. And if we know this angle, we can maybe use a law of sines. So what we want to do is we want to try to find a triangle. And this is what we have, is we have this triangle right here. Okay, that we want to use. All right, so let's start figuring out some angles. Well, I can figure out this angle, okay, because this angle is actually 90 degrees. And we can actually figure out this angle because this actually creates a linear pair. So we know that this angle right here is going to equal 20 plus 90. And if we subtract that from 180, that will equal that angle right there. So if we put that in a calculator and punch that in, we'll have 110 minus that, it should be 70 degrees. Okay, so that angle right there is 70 degrees. Now, if that angle is 70 degrees, all right, we have to know what this angle is. All right, now to figure that angle out, we can also figure that angle out by using this, because this angle and this angle are equal. This is one big bad geometry problem. So if you take this right here, and we can find that angle by taking, well, once again, we have a triangle. We have 12 degrees plus 90 degrees. And if we subtract this from 180 degrees, okay, that's going to equal, you guessed it, 78 degrees. All right, 78 degrees. So that angle is 78, and that means these are vertical angles, so that's 78. And so now the question is, what is this green angle right there? Well, this is 70, this is 78. Well, this one is going to be, well, 180 minus the quantity of 70 plus 78, which actually equals 32 degrees. 32 degrees. So this is angle 32. This is 70. This is 78. This side is 16, and we're looking for this side H. It says draw a triangle that represents the problem. We did right here. Then show the unknown quantities on the triangle and use a variable to indicate the height of the flagpole, which is H right there. Okay, so we figured that out. Write an equation involving this. Well, what can we use? Well, this is not a right triangle. Well, this is the right triangle, but this one is not. It's an oblique triangle. We know this side, and we have an angle. And so essentially we're trying to figure out this side right there. So we have like an angle side angle or angle side. So if we have angle, angle side, we can use law of sines to help us solve this. And so what we're going to do right here is we're going to take the sine of 70, and that is to 16, because that's one opposite. And that's going to equal the sine of 32 over h. And that's our proportion. To solve for part C, we're going to cross multiply, and so h should actually equal, all right, 16 times the sine of 32 divided by the sine of 70. And there we go. Which, if we put in our calculator, is approximately about 9.03 meters, or if you want to round to the nearest whole number, 9 meters. Okay, so that's about 9 meters. So a flagpole is approximately about 90, 9 meters long. All right, and we just solved the problem. So key things are use the information you give. All right, understand what the horizontal is, 9 degrees. Find the slope of the angle going up this way. Draw in your angle. When you talk about angle of elevation, that is always to the horizontal and going up, like so. All right. Use the other triangles to solve for the triangle you want to find. All right, all the angles. Plug in the values, and then go to town and solve that problem. All right. Well, I hope that helps you out. A little bit of a complex problem, but one that was pretty fun. A lot of cool geometry in this one. And we found a flagpole equals 9 meters. What more can you have in just one single problem? So hope this helped you out, and yeah, good luck and God bless the rest of your problems.